Welcome to the Real Python Podcast. This is episode 254. What goes into scaling a web application today? What are resources for learning and practicing DevOps skills? This week on the show, Calvin Hendryx-Parker is back to discuss the tools and infrastructure for autoscaling web applications with Kubernetes and Karpenter. Calvin is the co-founder and CTO of 6 Feet Up, a Python and AI consultancy. He shares how they recently helped a client scale a web application that employs video, audio, and chat sessions. We dig deep into the tooling behind modern Kubernetes, systems management, and performance monitoring. Calvin shares a project bootstrap tool for streamlining the development and deployment of a web application. The tool includes a complete blueprint for the infrastructure needed to get started. We also dig into a collection of coding tools Calvin has been experimenting with. We discuss his recent IndyPy presentation, Battle of the Bots, which put several AI code assistants through their paces. This episode is sponsored by AMD. AMD invites you to create AI innovations without barriers and scale your projects with resilience. Whether you're developing LLMs, building models, or optimizing PyTorch pipelines, AMD empowers you to do it all, openly and without limits. Follow AI at AMD on X for exclusive updates and resources. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Calvin, welcome back.
It's good to be here.
Yeah, it's fun to talk to you again. We're going to go in a slightly different direction today, which I think is cool. We're going to talk a little bit about scaling. I've had people ask before to cover this topic. So when Laura kind of reached out and said, Kevin wants to talk about this and this project he's working on, we'll be talking about larger projects. And one of the things that I was wondering about is this idea of like, just literally, can people get their hands on this stuff? And so we're going to try to come up with some ways that people can play with this a little bit on maybe their own desktop machines and so forth without, exploring, because like a lot of these free tiers have disappeared.
Yeah, it's unfortunate.
Which is kind of challenging. Yeah. So what have you guys been working on at 6 Feet Up?
So it's been a fun project, actually. The one we're referencing here is the ability to scale up a Django application beyond, say a single EC2 instance just running Django for you, and maybe you've got a Postgres database on there.
Okay.
When you get into the realm of, this is kind of something we did for the Loudswarm project too. So like when we were running Python Web Conference and we had the Loudswarm application that we wrote to host the virtual event.
Yeah.
There were a lot of kind of back-end scaling things that were new to us at the time. This has been years ago. That started in 2020, where as you start dealing in like WebSockets and real-time applications and voice applications and chat and like you kind of got live agent type applications, you start building up memory usage on like each session that's actually happening in real time. If we think about the web, historically, it's been a stateless protocol. HTTP itself is stateless, but these more modern applications are actually starting to maintain state with the server or sessions with the server where you're having a conversation, like a voice conversation back and forth. And so that has to have some server side component to it. And now you've got a scaling problem. If you've got 10 callers and you've got 10 listeners on the other side, each WebSocket takes up some amount of memory, or each call into the server for a chat can spin up a container, for example, to handle the call. Well, 10 is fine. 50 is probably fine. As you're starting it into like thousands or tens of thousands of these kinds of calls, you can't put that on just one very large server. You need some kind of scaling or orchestration platform that's going to help you deal with that load in a sensible way and can kind of garbage collect the old containers when they're done, when the calls end.
Okay.
So that's actually a problem we ran into with this project was specifically every interaction with an end user would actually spin up a pod inside of a Kubernetes. We were already doing Kubernetes for this project. So every interaction spun up actually 4 containers in a pod that would interact with the end user on a phone call, for example. Well, when you started saying we're going to release this to the public and they wanted to kind of go to market strategy and they're like, well, how do we scale this up? There was a big, kind of realization that, there's going to be a big bottleneck here around how we scale this up on the current infrastructure.
Yeah.
So more than just like kind of add more EC2 instances to the cluster as nodes, there's actually lots of other not strange, but was new to us scaling considerations you had to look at. For example, so we're using EKS on this project. This is on Amazon. EKS is the managed Amazon Kubernetes service, which I would recommend it.
Does EKS stand for something?
Elastic Kubernetes Service.
Okay, Elastic.
Hopefully, if that's right, and they'll let me keep my heroship. But
there you go.
So I would recommend if you're new to Kubernetes, probably looking at some of these managed Kubernetes services, mostly because there's something you have never dealt with before in Kubernetes world, which is there's a whole concept of a control plane.
Okay.
And that control plane has like the scheduler, and it controls like where tasks and things like Django or like Celery jobs and cron jobs, all the kind of things that would operate inside your application. It decides where those go on the various nodes that you spin up as EC2 instances inside this infrastructure. The issue is, we had a EKS running. It's got our control plane, got our back. We're running Postgres inside the cluster using Cloud Native PG. We start spinning up additional services. We've got Django front ends. We've got like a Mosquito MQTT broker. And so the number of containers and services all starting to pile up in this project. And now we're starting to spin up jobs and containers specifically for each of the calls. Each node in an EKS cluster has a limit to the number of IP addresses, and therefore the number of pods that you can spin up inside a single node.
Okay.
And again, this all depends. It always does on the size of the node, the kind of the node, the number of elastic network interfaces that node can have. So in this case, we were using R4A extra large instances. And so that's a specific instance type that's kind of recommended for Kubernetes clusters on EKS. But it has a maximum number of, 58 pods that you could possibly spin up on a single node. If your pods are fairly lightweight, you're not going to use all the resources that maybe that instance size has, like the amount of memory you've got, the amount of CPU you've got. You've hit another constraint, which is like number of IP addresses, basically, that node can apply to those various pods.
Okay.
Now, there's ways around it, but one of the things you can do is you can start scaling horizontally with Kubernetes by adding more nodes. And so there's a Kubernetes autoscaler built in, but it's got some limitations, or it was an option. We looked for a better option. We actually found an open source project called Karpenter, which is actually open source by Amazon. So it's meant to work with EKS and Amazon in EC2. And what it does is it looks at your current number of pods or number of pods that are being scheduled for jobs on the cluster. And any jobs that are unschedulable, it'll kind of queue those up. And if you get, depending on how you configure it, it can spin up new nodes automatically on your behalf, spot instances that can be cheaper. You could have certain kinds of tasks that go to certain kinds of node groups. So if you got a node group that has GPUs, maybe you're doing batch and inference in the middle of the night. And so you want to spin up spot instances that have GPU capabilities so you can get cheaper prices. You can have Karpenter actually manage those unscheduled pods and put them onto there. And in our case, we just wanted to be able to spin up more nodes to handle more calls so we could scale this horizontally.
Just traffic.
Yeah, just traffic in general.
Okay. If you're okay breaking down some terminology.
Yes, absolutely.
Yeah. So Kubernetes, just to take it all the way down to the bolts, like Kubernetes is managing containers. And so when you use the term pods, that's potentially a group of containers, right?
Correct. Yeah. It's like if I've got a Django backend pod that I may say I want some number of replicas of it because I'm load balancing, for reasons. So you can scale the pods, horizontally inside of the node.
Okay.
You can scale across multiple nodes to have resiliency. So Kubernetes is that orchestration layer that can do all this for you.
Yeah.
A lot of people's objections to Kubernetes are the complexity of it, but the tooling for Kubernetes has gotten a lot better.
Okay.
I feel like that it's that's not a real concern anymore, at least
Okay.
for me. It hasn't been a concern, maybe just because I've gotten more familiar and accustomed to it. But I feel like the tooling out there to manage and run and maintain and play with Kubernetes clusters has gotten a lot simpler.
Okay. So it was much
Yeah.
more manual
Yeah.
before, as far as like
A lot of
creation
YAML.
and building. And
Whole lot of YAML. It
Okay.
still is a whole lot of YAML, but I feel like that there's some nice tools like Karpenter. We also use one called Customize.
Okay.
Because we want to be able to manage Kubernetes not only in the production environment, but also want a staging environment, a sandbox environment,
Okay.
the local developers environment. And we use Kubernetes front to back, like from the developer experience all the way through to the production experience. So that it's containers forward and backward, and it all works alike, and it's all controlled and configured via the same set of files. So something that should work locally should work, or something works in production or doesn't work in production, I should be able to reproduce that more easily on my local instance.
Okay. And that's something that, as it's matured, you feel like the tooling has matured with it as people are using it and figuring it out. And so Karpenter is, again, an Amazon tool. It's spelled with a K.
Yes, it is.
Like
all
again,
the Kubernetes tools.
Stuff. Yeah, exactly.
Customize, also spelled with a K.
Exactly. So just pay attention. And that tool, like I have a link here that I can kind of give people to, that is a sort of a tutorial that people can kind of look at, get a little of an idea of it.
Yeah.
And then the idea of Plane, this tool that's going beyond that. I maybe describe that a little bit. Like, what is it kind of doing for you? This, did you call it
the control plane?
Control plane.
And I feel that for me, the Kubernetes control plane and the fact that Kubernetes has an API is its killer feature for me.
Yeah.
Like if you want to be able to do things like full CI/CD, so continuous integration, continuous deployment, where if the tests pass and they've merged it to main, the PR got accepted, it can release automatically into your sandbox or even into your production environment. That is enabled by tools like Kubernetes. The fact that my CI pipeline, like my GitHub Actions, for example, can spawn, as a PR is approved and GitHub sees it and like now triggers an action, that action can release the newest built container into whatever target environment it needs to. And the only reason it can do that is because it has an API that our internal tooling can talk to.
Yeah.
If you're using things like Docker Compose, or if you were just spinning up those containers using the Docker command, you're still stuck in a world where you're shelling into the box and having to pull the containers to the box and launch them.
Okay.
So it's a step better than, go to the box and do a git pull and pray. You can now have the automation tools in place so that humans aren't or less likely to kind of mess things up along the way, because it's all controlled by this got tagged with that version. We want to make sure this version of that image is released to production. If there's any errors in that release to production, we would want that thing to roll back automatically and not leave the site in a broken state. And so between tools like we use Argo CD for our continuous deployment tool, between Argo CD and Kubernetes and GitHub and our actions, like that all just flows nicely. Like it's a really, really smooth experience once you've got that control plane available to you, because the control plane now can receive new configurations for the deployment. You can say, well, we were using this image, based on this URL and this tag. We've updated that tag. Now go look for this new tag, and it'll go grab the latest image, and then it'll spin up the pods, make sure there's traffic starting to go to those new pods, and then tear down the old pods when the traffic is gone, has subsided from that. So you basically can get these zero downtime releases. Like that's the killer feature for me for Kubernetes is this controllability from automation tools.
It's time to shine a spotlight on another Real Python video course. While LLMs are remarkable by themselves, with a little programming knowledge, you can leverage libraries like LangChain to create your own LLM-powered applications that can accomplish so much more. This course is titled First Steps with LangChain, and it's based on a tutorial written by Harrison Hoffman. And in the video course, Martin Royce teaches you how to use LangChain to start building LLM-powered applications, create usable instructions with prompt templates, create and extend LangChain chains, and debug what happens when a chain executes. Real Python video courses are broken into easily consumable sections, and where needed, include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com. So how are you doing the configuration? You're saying that you've scaled back some of the YAML stuff that you've had to do sort of manually in a text editor and building out. Is this tooling still some of that, or is it got a GUI interface, or what? Again, you mentioned an API, so you could be writing, I guess, scripts to be doing this.
You could write scripts to go against it. We still use YAML to configure. Well, actually, there's a good example of this. If you wanted to check out the scaf project on the 6FUP GitHub.
Okay.
So it's just github.com/6FUP/scaf, SCAF.
Which is short for scaffolding.
Yep, for scaffolding. That will give you a locally running Kubernetes instance using a tool called Kind.
Okay.
So if you want to run Kubernetes locally, but don't want to run all the monstrous machinery that makes Kubernetes, Kind will run it in a single container. So it's very lightweight. And then you can try out all these things. You can actually see the configurations for local, and they get applied across like a base set of configurations. So the base configuration says you're going to have a Django backend, you're going to have a Next.js front end, you're going to deploy a Mailhog for like simulating email, you're going to deploy a Postgres instance, so we have a database, a Valky or a Redis instance, so we have some kind of object cache stuff there. And then you can see that the local instance of them use these settings, and the sandbox instance uses these couple modifications. Like there's a different database string. There's we're going to launch into this AWS instance with this VPC and this control plane for Kubernetes. And then production has yet again these refinements to that set of settings. So you're not duplicating all the infrastructure and deployment YAML pieces for every environment. You're just using the tool called Customize, make these subtle changes that are different for production, and different for sandbox, different for local.
Okay.
Because in local, we want to run full debug modes and all the logs and everything kind of going on. In production, we want none of that stuff, happening. So they're slightly configured differently, even though they're both running potentially the same containers.
That sounds like a really neat project. Can I ask you, what have been the benefits of designing that for your internal team?
Oh my gosh. It's codifying exactly how we think about deployment and developer experience and production and all those things that because we're an agency, so we work on many clients' projects each year,
right? As
opposed to if we were just a product company and we had a single thing we were working on.
Yeah, you guys got to bounce around to lots of different things, and and if you can share a language, right, of how we do this.
Yeah, exactly. We want to share how we deploy our tooling out to our customers.
Yeah, that makes sense. Yeah, that's cool that you're sharing that. So, if somebody wanted to get into that, they could duplicate the repo and build it up, and so forth. And there's, I guess, containers that are sort of attached to it and so forth. I
gave there's a presentation from Pi Ohio from last year, and then I also was on the Talk Python to Me podcast earlier this year talking about the scaf project specifically.
Oh, okay, cool.
But
we'll link to that.
Yeah, you should link to that. It's a really easy way to get started with a bunch of our opinions about how to deploy a robust Django application.
Right. Yeah, because I think that's kind of the problem, is that people see all the tools that are out there, see what this universe of things are, but have very no idea of well, how do I tie these things together? And even if they want to make other decisions than they have, at least they could see how a piece of art has been completely glued together.
Right. At least one example. There's some art here. You can learn from it. You can admire pieces of it. You can you can copy.
Yeah.
And make your own version of a piece of art by remixing. I feel like that's a good analogy. It's kind of like our work of art that you're welcome to steal from, because it's open source, and it's just, again, you don't need all the pieces. Actually, we just split up scaf into multiple templates now. So there's a full stack Django app. Now we have an AWS serverless scaffold that has our opinions about deploying an API gateway with a Lambda and a Dynamo as a really, really small little example application. So it's not strictly related to only big Kubernetes Django type applications.
Oh, cool.
Yeah.
So I derailed you.
yeah, we got off the rails there a little bit.
No, I think it's good though. It's good stuff. So I'm trying to think of where we were. Like you kind of talked about like why you sort of landed on this tool.
Yeah, we were talking about control plane, and I think then I don't know if there's any more definitions or with 3-letter acronyms you wanted to get
Got most of them. Yeah,
clarity on. Yeah,
because we mentioned Karpenter and we mentioned EKS.
Right. Well, the next thing I think would be important to talk about would be how do you identify you have a problem, and then how do you reproduce the problem so you know if you fixed it or not. So things like observability and load testing tools are really important here. So we've used a couple different load testing tools over the years. One of my favorites is Locust. It's a Python-based async load testing tool where you write the load test in Python. You can do load testing against WebSockets. You can do it against HTTP. So it's pretty versatile in how you use that tool to actually build your own load tests. And then you can cluster it. So you can actually test and generate a tremendous amount of load by like scaling the Locust clusters out. So you can actually have a kind of a command and control of multiple nodes that will then attack your...
That's where the term's coming from? Like,
attack
we're being
site.
Attacked by locusts?
Yeah, exactly.
Like the plague.
I mean, in the end, and you also have to have something on the other side that's measuring what's going on. So tools like Grafana and Prometheus and Loki are key to be able to observe the action of spawning 10,000 calls against this platform. Like what happens? Where does it break? And what are the constraints that you're dealing with? Like in our case, it wasn't CPU and wasn't memory. It was this arbitrary, well, not arbitrary, but like the number of pod limit that could be spawned on an EK. And again, this is EKS specific. There are also some workarounds, but we had to be able to identify where your site breaks with your kind of workload.
Yeah, that's what I was wondering, like the specifying the workload type, because you mentioned, you're dealing with this sort of call situation, which is very unique. And Locust was able to be configured in a way that it could behave like that?
Mm-hmm.
Okay.
Yeah, and in the end, we did some more like kind of iterations on the load test. We didn't really need Locust to identify we identified the problem, but then to really pinpoint and exercise the problem, we didn't actually need Locust for it. We just wrote some Python scripts. We switched over to Python scripts when the simulation of many users wasn't the critical aspect, just to simplify. So Locust is a good place to start, and then you may find that to really hone in on a specific performance piece, you may write some other custom scripts or whatever it is to exercise whatever that performance problem you're trying to exhibit is.
So I have another question that you kind of hinted on a couple times now, where it's sort of like this address space thing that was a bit of a hiccup that you're dealing with.
Yeah.
So I know that's a big part of configuring AWS type projects, is that you got to get in there and then sort of say, okay, what are the IP things that I'm kind of setting up? Like, what does that even look like in this situation where like the pods get like a certain set of addresses that they can be sort of used and then talk to, and
so internal to a Kubernetes cluster itself, you're going to have ingress, so some way that traffic gets into your cluster.
Right.
By that, you can have ingress of like HTTP calls. They go to a load balancer, and that load balances across multiple Django instances. In our case, we had WebSockets, so we had to have some kind of ingress for WebSockets. But they all have there's an internal networking, and there's nothing magic about it. It still uses IP addresses. You can, by default, it uses IPv4, and it'll use private, internal addresses that don't route to the internet, kind of like you use on your home network, type addresses, but it's just using it inside this cluster. There were maximum numbers of those IP addresses that could be assigned per EIN, which is a Elastic Network Interface.
Yeah.
And depending on like instance type you have, some of them have support for multiple ENIs on one EC2 instance. So there's where you had like how many IP addresses could be bound to a single interface, which was part of the problem.
Okay.
So if you've done much work with Amazon, or if you've done scaling work on Amazon, you'll run into there are limits and quotas for every service out there. And I think some of them are conservative because they don't want you to overrun your budget or spend or use resources you don't need.
Big surprises.
Right. And I think that this specific, the default EKS running option where you can put like 58 pods, for example, on an X large instance size. I think it was really so that folks didn't point a foot gun in the wrong place and pull the trigger.
Okay.
Because there is actually an option to up that to 110 pods per any size EC2 instance. If you did this, there's a CNI prefix flag that you pass to your running configuration of your EKS cluster. And then at that point, the new nodes can actually have up to 110 on them, depending on which kind of size it is. There's some bigger ones out there as well. But then you can quickly cause other kinds of problems, because you've now enabled lots of power. So with great power comes great responsibility. The whole Spider-Man thing definitely applies here.
Yeah, and potentially price tags.
Mm-hmm. So you have to be willing to pay for it too.
Yeah, exactly. Yeah.
So I think that's what if I had to say what was going through the AWS engineers' minds when they were designing the service, that was probably part of it. Was let's put in some guardrails that keep people from going too far off track.
Okay.
Because why would you spend up 100 pods on a single node? Like, that could be crazy.
So when you use these, there are observability things inside of Amazon's tooling.
Yeah.
Why would you choose, say, something like Grafana or these sort of outside things? Are they giving you special tooling that's going to work better in your situation, or
possibly?
Why would you pick that? Okay.
I mean, there's all the data you can get off of the CloudWatch metrics you can pull into these external tools. Okay. And you can also pull in your own instrumentation into these external tools. And I find the usability of them as a developer or as a DevOps person to probably be a little easier to use, a little more friendly than if I was just going to go down, I'm only going to stay in the Amazon world. I'm only going to use CloudWatch and CloudWatch metrics and CloudWatch dashboards to do all this. It's gotten better. I'll say CloudWatch has gotten better over the years, but early days it was rough configuring it, and the UI is clunky, and but I find that
I looked at all this stuff 5 years ago. I have no idea if I'm sure it's improved, but still it felt rather clunky at the time. So,
but the combination of Prometheus and having like those sidecar or the Prometheus metrics coming out of your app, sending your standard out logs to sending your logs to standard out so that they can be captured by a tool like Loki, and then using Grafana as a front end to all that. And people have made tons and tons of open source, nice Grafana dashboards. So if you've just got a plain Jane vanilla like Kubernetes cluster out there running, there is a Kubernetes Grafana template you can go grab off the Grafana site and just copy paste the number, the ID of that template, and boom, you've got beautiful looking charts and graphs that show off your currently running EK, or Kubernetes clusters, for example.
Okay.
So, and then you can customize from there. So I like the tooling I like Grafana. It's again kind of a little more beautiful, a little more pretty. It's got alerting tools built into it too. So I just feel like you can pull more into it from other things, not just the AWS stuff. So if you've got instrumentation in your application itself, you want to pull that in. If you got other like real user monitoring stuff going on, you can pull that in.
Okay. And this Loki is their tool for ingesting logs, managing them, and it doesn't matter, like you said, the platform necessarily they're coming from.
Right. And it's got nice support for structured logs. So if you are outputting custom metrics into your logs using structured logging, you now get those as metrics inside your Grafana dashboards. And so you can start graphing them and charting them or searching through your logs. If you're triaging problems, it's so nice to have all that stuff, all that data in just a single, I hate to say it, single pane of glass that you can go get that observability from.
Right. Yeah. Got the extra monitor on the side.
Yeah. I got
those things.
Somebody just won the enterprise IT bingo by me saying single pane of glass, I'm sure.
Okay. Yeah, we don't say that word as much as often here.
Right.
Yeah. Okay, so we've talked a little bit about the project and some of the tooling that has helped you kind of get there. I'm not sure what else we want to kind of get into with it.
Well, there's some more lessons learned on that one.
Yeah.
The fact that we were spawning pods per calls, for example.
Yeah.
As an initial implementation worked, but it probably won't scale. Like, and even though
I think about like just the time for it to turn on, like to...
They're super quick though. Like,
oh, really?
Because the containers, the images for those containers are all sitting in the cluster already. So turning one on is like starting a process. Like it just turns on. It's not like you're spinning up an EC2 instance and it takes 10 to 30 seconds. Like,
yeah, that's what I'm thinking of.
Now, spinning up another node into your cluster could take up to 30 seconds, and there's some cool open source tools that have gotten that timing down. I mean, you could spin up a node in a matter of like 2 to 3 seconds into the cluster and have it start servicing requests on new containers that are launched into it as new pods. So that is possible. The next step, though, is like going from thinking about your application. Like there's probably a need now to refactor the application and actually build a way for a single pod to handle multiple calls, for example. And so you can, one of the things we did was we're refactoring the application to go from spinning up 4 containers in the pod to handle the call, like kind of recoding that into like maybe one container so that you don't have the overhead of each container's overhead multiplying by 4. So you kind of can get down to like 25% of the size of memory usage, for example, for that pod. And then you can now pack more into a server. And that's when it becomes important for us to be able to have more than 50 pods per node that they're there. And then the next step after that, after we refactored from like, say, 4 containers down to 1, is going to be having one pod be able to handle multiple calls. Now you can scale, again, kind of more vertically inside the application instead of like having to add more hardware necessarily. So it depends. And this is where it's like scaling becomes an art, is you have to be able to know what to look for, what to monitor, what to observe. Your application and your workloads are going to have kind of unique characteristics that you are going to have to learn and understand so that you can effectively scale your application up. There's no golden rule for, you can just keep adding more servers, but you'll probably be really wasteful. There'll be lots of idle resources. Like the thing that containers and Kubernetes and all this brings to the table is the ability to actually pack more load into these very modern servers. Like they have a tremendous amount of CPU power, a tremendous amount of memory that you can pack into them, but you still have to be able to take advantage of it, so you're not just burning money for having a big VM instance in the cloud.
Yeah, that makes sense. Yeah.
And when the traffic goes down, you want it to be able to scale down. When the traffic goes up, you want it to be able to scale up. And that's where tools like Karpenter come into play. The fact that it can auto scale based on demand and load or memory or number of pods, or you can actually, we manually instrument it a little bit so that when we get to, say, a 70 or 80% threshold on the number of calls on any one node, we artificially launch a very large shell, like a container that does nothing. It's a no-op basically, but it goes into the scheduler and requests a tremendous amount of RAM, like more than would fit on the current node. And that's
so this is like the playground is open for us to put more things inside.
Put more things into it. So all it does is it launches that one container, goes into the unschedulable queue. Karpenter sees it, goes and gets another node, puts it into the cluster, and then we immediately, like I think 10 seconds later, kill that container. But new calls now start going over into that
other space,
newly spawned node. Ahead of time. So it's kind of like pre-warming it, because it was taking 30 seconds to put a single node into the cluster. Now we found another approach. We think we'll make that faster, and we might be able to get around that hack of like launching this artificial container with a bogus, no-op in it to do it.
Yeah.
But that's kind of that's the state of the art right now. If you wanted to pre-warm a node before you got to the end of your capacity, you would need to do this technique, for example.
Okay. Yeah. So at the 80%, you're like warming up the car for
the next car load.
Exactly. Yeah.
Get the second bus going.
Exactly. We're going to be loading them up too.
Mm-hmm.
You keep mentioning the word call, and I know that you do stuff, with audio and video, and have done that for a long time now.
Yeah.
Are these audio sessions then, or what are they that they're
they
doing?
are they're audio sessions. So it's a live LLM like chatbot where you speak to it.
So it's doing speech to text stuff.
If you like, kind of like how if you launch ChatGPT and you went into the voice mode, and you can talk to it. It's just like that. And I think this specific application also has a video avatar that can optionally be attached to the session as well. So it lip syncs to what you're saying,
Okay.
and what the avatar should be saying. It'll be lip synced as well.
Okay. Interesting. Okay.
Yeah.
Yeah. It's a big project.
It's interesting. Yeah, it's a project that came to us. It had been going for a few years before we got a hold of it, but we ended up refactoring it and relaunching it and making it so it could scale.
How often does that happen for you guys? Is that a pretty common occurrence?
I would say it is that, go to market sometimes doesn't look the way people imagined when they get there. And so
and the scaling thing is like literally what we're talking about. Yeah.
yeah. So there's groups like us who they can come to kind of rescue, save their bacon kind of a project or make it real. We had this idea, it's cool, and it worked for like me and my 5 friends, but now we want to do something real with thousands of users.
Yeah. We're gonna actually have
real load.
Turn the faucet on.
And hopefully make money, right? Because otherwise...
Yeah, that's true. Yeah.
Why would you want to do it?
Exactly. What does the evolving intersection of AI and OpenStack mean for developers? AMD knows innovation starts with developers and grows through partnership, sharing, dialogue, and ingenuity. AMD invites you to experience its open community made by developers for developers. Follow AI at AMD on X for valuable Developer Central resources. That's AIATAMD on X. Are there limitations that are in place based upon some of the tools that you use, like the databases you use or Django itself that kind of come into that factor too? Or is it mostly the stuff you're thinking about with like, the pods and the connections and things that you have to think about?
No, it's you again. It comes down to your workload. Like for the LoudSwarm, when we did that application, we spun up separate containers for the Django HTTP part of the application, and we spun up separate Django containers that were tailored to running the channels, like WebSocket piece of Django, because they had different load characteristics and different scaling need characteristics. That one was a little more by hand. We knew we had an event coming up, we would go literally change the number of nodes or containers that were launched by hand and apply it, and then poof, there'd be more capacity.
Yeah.
Tools like Karpenter fix that and can make it a little more automatic for you based on
threshold limits like you talked about.
Yeah. But there's some cool, like for example, there's an open source project out there called EKS Node Viewer. And so we've been using that to just kind of manually watch the nodes. It'll show you CPU and memory and other stats around the nodes. The actual EC2 instances that are hosting all of your pods. And so that's really handy as a developer or as a DevOps person, so you can see a little more real-time stats into what's going on. If you've not played with, there's a tool called K9s, which is a GUI, text-based GUI for your terminal that you can attach to your Kubernetes cluster and see see the running pods and see the memory usage and disk usage and IO. It's kind of like BPyTop or HTOP but for Kubernetes. So you can see kind of a top-like interface for all the stuff going on inside your cluster.
Okay, cool.
Yeah.
All right. What else were we considering here? You had kind of broken it down.
We talked about the node viewer, building custom metric scripts, things like that is important. But it comes down to your workloads. You have to know what your application itself is trying to do. But another nice thing with the Kubernetes having an API and a control plane is that your application can interact with that control plane. Like you can build, not even having to build your own operators, but you could build your own Kubernetes operators that can act upon the Kubernetes cluster itself. Like if your application knows it's calling for specific kinds of resources, that control operator or that operator could actually go out and spin up infrastructure as kind of like Karpenter does, but you could do other things like that. For example, when those calls come in, we have a container or pod running. It's like a service manager. It just calls the Kubernetes API to spin up, the pod to handle the call.
Yeah, it's interesting to me that you're talking about this idea of the thing managing itself a little bit.
Yeah.
How do you configure that? Like, where is that configured through like a script then, or
Python code. There's a Kubernetes Python API SDK that you can import into your running containers. So some of these containers just have an entry point that is a Python script that is running, in like a loop or whatever, and it's listening for events or watching for web calls, and then delegating those tasks or activities to other places in the cluster.
Cool. One of the things mentioned in the preview we were going to talk about is performance tuning around Django. Is there some of that there too?
There is. I mean, for example, using things like Redis for caching is super important. I think what else we've done around some of it comes down to performance tuning, like all the pieces around Django. I think is important.
Okay, so the additional, because you use this term pods again, I know I'm keep repeating some things. Just I want to clarify, like that pod is potentially going to have individual containers that have. I had thought that maybe I guess this might be again a performance thing. That would you in a container just have one application running, or would you potentially have
typically?
Okay, so you don't like stack like three things inside of a container.
I wouldn't unless there was a performance reason to go the other way, like mentioned before.
And that's why we go with a pod.
Yeah. Well, the pod running, I would have the pod be... The pod is the mechanism by which we're managing an instance of containers that have been deployed into the application or for the application.
But the pods would inside the pod, there would be a container for Django, a container for a database.
Actually, in that case, you'd have a pod per each of those components. Like we'll have a backend pod that's running Django. We'll have a database pod running Postgres. We'll have a Redis pod running Redis, for example. Okay. And then then you can have them have their own configurability or scaling attributes. So you may want to say that the Django pod has to have a minimum of 3 replicas.
Oh, okay. All right. So it's maybe multiples of the same thing that is making the pod. Okay. I was thinking the pod would be like multiple items that are different from each other, but not be multiple instances of the same thing. So okay.
Yeah.
Sorry.
Yeah.
It tells you how often I've dealt with Kubernetes like builds and like again, just example applications from years ago.
Yeah.
So is this something that you've learned as infrastructure technique in Kubernetes?
It's just kind of the core. That's some of the core concepts of Kubernetes. Like I'm by no means I am not a Kubernetes expert, but but we've learned and baked our assumptions and opinions into like that scaf template, so that people can go and just deploy something that should just work out of the box, because people who are Kubernetes experts have kind of expressed those opinions into that template for us.
Okay,
as part of our team.
Okay, cool.
Yeah. I guess one thing we didn't talk about is cost. Like if you are scaling into the cloud, you really need to be aware of cost considerations as well. I didn't mention this before. One of the interesting aspects of the Karpenter tool is it will talk and use the AWS Fleet service internally to calculate what might be the best sized, best shaped EC2 instance to launch into as your next node.
Okay.
So you can actually not just say all of our nodes are going to be R7A X larges. You can say, Karpenter, you can pick between large, X large, 2X large, and you can pick between R instance types or M instance types or C instance types, depending on what's available spot instances, what's available cost-wise, what the unscheduled pods characteristics are requesting. So when a pod launches, it requests resources. So it'll request memory and CPU resources.
Right.
This does some calculations on your behalf to try and find a best cost combination of things to what it should deploy next. So if you give it some options, it can take that into consideration when launching.
Okay. So this is kind of like a play on words with sort of fleet pricing. Kind of totally. Idea.
Yeah.
Okay. All right. That makes sense. One thing that we touched on before we started was the idea of running things locally. And again, going back in time, the answer was Docker desktop and kind of doing that sort of stuff.
Oh, yeah. Yeah.
I was trying to ask a few other people about like, what do you use in this case? And they were like, I don't know. And I'm like, oh, I'm going to have Calvin on. He'll have played with these things. So you were saying that you were using I'm trying to remember the name. Was it
OrbStack?
OrbStack. Okay. Yeah.
Yeah. So I'm on a Mac. I've got a M4 MacBook Pro, and I'm using OrbStack to be my local Docker desktop replacement. You can use Docker desktop. I mean, depends on
Right.
where who you want to support and what features you like out of the products. I found OrbStack to be really fast,
Yeah.
and I liked its workflow, and it's just got the right amount of features I needed, which is pretty minimal. And I don't use the Kubernetes piece built into OrbStack locally. I use Kind to run my Kubernetes clusters, which is nice because then everyone on my team is not running a Mac and everyone on my team is not running OrbStack. Like some of the people on my team are on Linux. I don't think we have any Windows people right now, but if there were Linux people or Windows people on the team, they could also be running the exact same setup as I am.
Okay.
Because we're using Kind to run the clusters.
All right.
So we're not saying you have to use Docker Desktop Kubernetes or OrbStack Kubernetes. Just any container environment, whether you're using Docker Desktop or Podman or OrbStack, those will all work.
Okay.
It should work the same. We've kind of got a nice abstraction layer in there, which is that tool called Kind, which basically lets you run a very lightweight Kubernetes locally.
Okay. Nice.
And it gives you a full control plane. It launches all your pods locally. Now, it's just it actually runs in a single container. So it's very, very lightweight, but you're not scaling. Obviously, you're not running this. This is not production. This is your local instance that you run on your laptop, your desktop system.
Yeah. For smaller projects that you're creating, is the tendency to kind of move toward containers? Is that still a
100%.
favorite development area? Okay.
For me, it is. Yeah.
Yeah.
I just containers, especially since we're got Linux, Mac people, and we deploy typically into a cloud someplace. I love that the containers just give me that. It's like a stable foundation to put everything into, and I'm sure it's going to run wherever I put it.
It works on this container, not this machine, kind of thing.
And you can have this container, and it works over there on your machine now too.
Yeah. Okay.
Yeah, I'm a big fan of containers.
Has that eliminated that problem for you?
It has. I definitely think so. Because we've been around 26 years. That back in the day, when we're starting on a project, if you wanted to add another developer to the project, we had this, getting started wiki page that said, install these 5 things, and hopefully they get the right versions of those 5 things installed, and then run these 3 commands to import the data, and run this one service thing to make sure that's up and running. And now you can actually start your development instance of Django, or at that point in time it was Plone and Zope. We were doing a lot of work on that. So there were a lot of tribal knowledge combined with some wiki stuff to get going.
Okay.
With the new world that we defined using our scaf template, you pull the project down, and every developer knows to just run make start or make setup or whatever the make. We have a make target in there.
Yeah.
And you're up and running. You can literally just open up your text editor, whatever. If it was PyCharm, VS Code, we don't care, and start making changes, and the stuff just works because you're not installing a database onto your local machine. You're not installing the Redis onto your local machine. And by the way, this project needs Postgres 14, and this project needs Postgres 16, and this project, it's really old, and it's using Postgres 9. Oh my God, it's good luck getting it running because it's so old. Well, there's containers for all that, and they all run.
Okay. Yeah, that's interesting to me because being a Python show, we have spent so much time just talking about literally, I had a show about lock files recently with Brett Cannon, of course.
Yeah.
And, I talked to Charlie Marsh about UV and just the tooling there. But when you get to this scale of the types of things that 6 Feet Up do and so forth, or literally companies are generally, you're going beyond Python at that point. You're going to the scale of all these other tools and so forth. And it feels like containers are still kind of the way to do that. And they're there's so much more portable. I mean, literally, that's the point of it, right?
Yeah, I love it.
Yeah, which is cool.
Yeah, because you're dealing with systems of things.
Right.
And what's nice about the containers is that it allows a developer still to be very productive in their own little space, their own little world, and they can try and break things and play and be a productive developer,
right,
without having to think too hard about all the other system stuff that's around it typically, which I think some people might fight me on the fact that I'm claiming Kubernetes enables an easier development environment, but I do think it does. If you have kind of taken the route we have with our opinions, you get all the developer funness and all the tools, all that kind of stuff baked in without having to think too hard. Like the goal being, if I had a brand new fresh laptop, if I just downloaded, the scaf tool onto it, which pulls in our opinionated version. Actually, one of the things we're moving towards, and this is we could probably have a whole other show about this,
right,
is using Nix to manage our environments.
Okay.
So if you haven't heard about Nix, it basically, you CD into a directory and now your world changes to be what looks like that project's version of Nix, of tooling. So if you've got specific versions of Black or specific versions of ISOR, or specific version of PyCharm, specific version of this and that gets now managed by another tool called Nix. That's something we're heading toward so that it's even more stable to work on a project that maybe have a potential to bit rot. So you haven't touched it in 18 months. You CD back into that directory and want to fire it up and start doing a bug fix on something. You may run into weird dependency stuff. You've upgraded your IDE. You upgraded like this and that on your local machine,
right?
And now stuff is busted.
We I don't know how many years ago we talked about dot files and managing that sort of stuff. Yeah, and this is kind of
like dot files, but for applications. Like you can manage specific versions of apps. Like you can have, 5 versions of SED, or for example, that match whatever each project needs.
Okay, nice. Yeah, so I'm wondering, like, what outside of the project that we've mentioned several times here, for people to kind of get in and play with it. If you were to bring on somebody new and they needed to learn these resources, they were like, okay, I'm a general knowledge person. I know all these different things, but I need to be better at Kubernetes. Like, where would you steer them? Do you have like resources you think, oh, this is a great place to learn this stuff and practice it?
Yeah. I mean, there's some great YouTubers out there who talk about this stuff. There's a really wonderful woman named, I think her Nana on Technology on YouTube.
Okay.
She does a great series on like Kubernetes and containers and
cool.
Things like Ansible and kind of DevOps-y type stuff,
right.
And AWS and cloud things. Like I think literally I went and watched her like 4-hour intro to Kubernetes video when I started embarking on this Kubernetes journey.
Okay.
And now I'm like, I now know what these words, line up to. And
yeah, that's the problem is it's like a whole vocabulary lesson.
It's the words,
like,
right?
Right. Yeah. I had this conversation with Rodrigo, who's started making a couple of videos for us recently, but he was using this old quote that's out there, like, you have the same amount of vocabulary as somebody like Shakespeare. It's just he has more idioms of like how you combine these things together, these ideas and so forth. And that's the problem. It's like the first step is to like, okay, just understand the vocabulary being thrown at you, but then like, okay, then how do these things tie together and the ideas and the concepts, and then you just kind of keep building up that stuff.
Her channel is called Tech World with Nana.
Tech World.
Okay. Yeah, Tech World with Nana. Highly recommend it.
Okay.
There's so many great YouTubers out there who talk about this. Although there's probably also some shady, half-baked ones too.
It's YouTube.
I can vouch for her. She's really good.
Cool. Yeah. Nice. So we often talk about what you've been up to. It sounds like you're going to be doing some more conferences soon. But where have you been this year so far?
So if you all are familiar with the All Things Open conference in Raleigh, North Carolina, the Triangle, it's a good open source conference. They started an AI version of their conference in Durham this past spring. And so I actually went and spoke there. The talks are actually online and really good quality folks were there in the room. So I'd highly recommend it.
All right. We'll link to that.
Yeah. And it's coming up in October so that you can also make the bigger version of the event. I will be there at that version of the event as well. So I'm looking forward to that one.
Okay.
I'll probably be at reInvent coming up here in the fall. I just got back from PyCon in May, which was really great. I really enjoyed Cory Doctorow's keynote. If you've not watched it, it's online on YouTube. Go check it out. It's it'll make you think, as he is one to do. So that was good stuff.
Yeah.
Oh, also, I'm speaking at PyOhio this summer.
Oh, cool.
And so I'll be at PyOhio. I don't remember which talk I'm doing there. It might be my Battle of the Bots talk, which I just did at IndyPy like 2 months ago.
Okay, nice.
So that one I do a live demo and I pull up and use 5 different agentic coding agents as part of the demo.
Bots.
So those bots. Yeah.
Okay, nice. giving them different tasks? Are you getting different winners?
Like same task to try and show folks like how each of them operate a little bit different from one another.
Okay.
Just so you can get a feel for like, oh, like the Claude code's going to do things like this, and Goose is really interesting and it does like this, and it's open source, and Aider Chat is like one of my favorites, and I like how it interacts with like the Git repositories. I also evaluated in there Cursor and Junie, from the Junie one from JetBrains.
Okay. Yeah. That's new. New-ish.
It is very new, yeah.
Yeah. Okay,
all
cool.
This is so new. Like, I mean, how many of these words existed like 9 months ago?
Yeah, the vocabulary again.
Yeah, totally.
Let alone using it. Yeah. Well, cool. Yeah, that sounds like a nice conference schedule for you. I figured I'd leave some time here for us to kind of dig into the weekly questions.
Sure.
Because we always kind of go pretty deep, which is great. What are you excited about in the world of Python right now?
I'm excited about the Python documentary.
Ah, cool.
I found out about it. I think they previewed it at PyCon, and it'll be releasing.
The trailer.
Yeah, the trailer opened at PyCon. Sounds like it'll be releasing with a world premiere at EuroPython this summer. So
cool.
if you're going to EuroPython, you'll get to check out the Python documentary. And I'm looking forward to it because I've got a lot of friends who are going to be in the movie.
Yeah. Yeah, I've interviewed a few people that are in it. That's cool.
Oh, sure. You probably interviewed most of the people in it, I imagine.
Yeah, well, trying to get there.
Yeah.
Is that something that's going to be like a paid for on the site, or do you even know like how
I don't know.
The regular public will watch it once it's out?
That's a good question. You should definitely link to the trailer.
Okay, let's see if there's more information hiding.
Yeah, more information. I have to wait and see, just like everybody else. Like when it comes out,
I was just like, I'm not sure if they would even get on a platform or not. But yeah,
we should sponsor a couple theaters around the U.S.
There you go.
And have have a film festival.
Yeah. So what's something that you want to learn next?
I want to keep doubling down on some of these agentic coding agents.
Okay.
I did that Battle of the Bots talk. I've been using a lot of Aider and a lot of Claude code and liking it. The up and comer that I really like has been Goose. But each of them are
those, like Aider and Goose. I've not heard of. Yet.
So
how is Aider spelled?
It's AIDER. So if you go to Aider, the URL is aider.chat.
Okay.
So AIDER.chat.
Okay.
I like Aider a lot. It's open source. And you can also bring your own models. So this is something I've been looking forward in these tooling is I don't want to be tied necessarily only to Claude. Like in Claude code, you can only really use the Claude models. Right. In Aider chat, you can have multiple models interacting simultaneously in the same session. So you may want to use DeepSeek R1 as your architect, and I want to use Claude Sonnet 3.7 as my coder. And you can even bring in like a weak model, which is kind of like doing the behind the scenes orchestration pieces. And so maybe that's going to be OpenAI 01 mini. So you can actually combine all of them simultaneously and kind of tune to what how your workflow works and what maybe your code base is like. You may find there are certain combinations of these models that work better than another.
Okay.
So that's one of the benefits of Aider. Goose is also open source. It's by the folks at Block. It allows you to bring your own models. And like Aider, you can bring any of those models I just mentioned.
When you say bring,
you bring your API. You put your own API keys into the system, and then you're now using the API for Claude or the API for however you want to run DeepSeek. I don't recommend using the DeepSeek hosted R1, but I use a couple of the hosted versions, whether using Amazon Bedrock or some other way of running those models, or you can run them locally.
So you can connect to all of them that you want, and if you have an API key.
Yeah, and if you've got Olama running on your local machine, you can run, for example, Mistral code. What's the Devstral? So Mistral just released a developer tools capable model that will run on a Mac, M4 or M1, any of the Apple Silicon. I'm not experimented on Windows or Linux. I don't have availability of that, but I've definitely got the Devstral model running locally. I've got an R1 model running locally, so that data never leaves my laptop. Like it's kind of, if you're thinking about privacy, oriented type things. Now that said, I don't know if you saw Simon Willison's blog post from like yesterday about the codecs now having internet access. There are definitely these tool capable,
could be leaky,
right? Bots could be sending stuff someplace because they can curl, and so you can limit them down to not being able to do posts or puts. So maybe you only can do gets, things like that.
That, I guess that would be how do we get the guardrails up for using these tools in this sort of situation? Yeah.
Yeah, and there's some good tools for that too. Is it VLLM? Is that the one I was thinking of? That it basically a proxy you can run locally. It can take advantage of like Olama, or you can give it your OpenAI API keys, and you can put in guardrails into it, and you can audit what it's doing, and it logs and tracks everything that's going on through it. So if you wanted to have a little more
observability again,
yeah,
on
exactly.
like what is it doing?
Yeah, you could do that.
All right, cool. Yeah, sounds fun.
I think that was VLLM.
There are a handful of these. When you talk about tying them together, like we talked at the beginning, like this smaller platform model could be the one that helps translate my instructions to the other models that are doing certain stuff. This one's doing coding, this one's doing some other kind of tooling or whatever. Is that MCP that's in between there, or that's
it could be
talking between it? Okay. Are you using other tools that are like that are allowing that connection?
It could be just conventions to text files. Like I've seen some interesting examples of folks who have set up multiple coding agents to work in parallel. And they've got, for example, a document-driven development methodology, and they set up a set of requirements files, and maybe in that requirements files, they got a bunch of task files, and they can assign the task files to the various agents that are running. And those agents can be running simultaneously, and those agents are also updating those text files. So the agents could leave notes for one another, like tell the DevOps agent, we need infrastructure for running our training models or something like that. And so it technically could do those things. You really have to be kind of a wizard of how you're going to orchestrate all of that magic to happen.
Yeah. I feel like this is the most interesting space that's happening, is the developers making tools for the developers.
Totally. And that's what I love about these agentic coding tools, for sure.
Yeah. That's sort of fascinating. I don't know how that translates into business models, into other kinds of things, which is, again, something we talked about just briefly at the beginning. That's the part that is a little sort of head scratching kind of thing. And I feel like also is losing a lot of companies a lot of money doing it. But this stuff, the hope is that, okay, well then if all these things are built and they can still be run locally or done other kinds of things, there could potentially be an inexpensive way to keep all of this wonderful tooling keep going while maybe these other ideas sort of do whatever they're going to do.
Yeah. Well, I think not everyone has the capacity to run some of these models locally. So like that DevStro model, for example, it's an open model. You can download and run it locally if you've got enough memory. Right. Otherwise, you can use one of the hosted model services that's out there to pay per token, or some kind of micropayment capability to support these various projects. Hopefully those places who are hosting these open models are giving back some of that money into the people building the models.
Yeah. That's going to be interesting.
Yeah, it'll be interesting to see how that money flows where.
Yeah, exactly. Yeah. What's the best way that people can continue to follow your work online?
Definitely LinkedIn. So if you just go to LinkedIn and search for Calvin HP or Calvin and Hendryx-Parker, I'm on Blue Sky somewhat. I don't know. I've ever since the Twitter implosion, I've not really found a spot where I'm interested in hanging out like that.
Yeah,
but and then you can actually follow IndyPy. We're doing we're still doing quarterly hybrid meetings, so we're very friendly to folks who want to join from anywhere in the world. When's the next one coming up? If you just go to indypy.org, July 22nd. So probably right around that time.
That's perfect.
Yeah, and it's going to be a cross meetup with Indy AWS, so it'll be kind of a very cloudy meetup.
There you go. A lot of stuff that we talked about today.
Yeah, totally.
Yeah, cool. Well, Calvin, it's always fun to talk to you. Thanks for coming back on the show.
Thanks for having me.
Thank you to AMD. Developers are relentless explorers, driven to solve problems and redefine what's possible. AMD believes in open possibilities. The possibility to embrace freedom, follow your curiosity, and create something amazing. Together with AMD, the only limit on innovation is your imagination. Experience open and advanced software from AMD. Follow AI at AMD on X to get the latest Developer Central resources. I want to thank Calvin Hendryx-Parker for coming back on the show this week. And I want to thank you for listening to the Real Python Podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python Podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.